Hello everyone. We are starting the video series for our subject Embedded System, and in this series of videos we shall cover the fifth module for a subject. So let's have a quick look at the syllabus for this fifth module. In this module basically we shall see the terms, few processes which are related to operating systems. So first I shall give you an overview about what are operating systems, what are process, threads, task and inter-process communication. Inter-process communication is the main theme for this module. So we shall see what is inter-process communication, what are the various elements related to inter-process communication or IPC. We call inter-process communication as IPC. So what are the various other terms related to IPC? So basically for this module I have referred the textbook Embedded Systems, their architecture, programming and design by Raj Kamal. So before we start our fifth module, let's have a quick recap of what we have been discussing so far. So in the first module we discussed or we came to know about what are embedded systems, what are the components of embedded systems, the hardware components, the software components, the classification of embedded systems and even the development cycle for embedded systems, various life cycle models and so on. So the first module gave you an overview about what are embedded systems. Later in the second module we came to the communication. Having known about these components, we decided to learn the communication between these components, which was serial as well as parallel communication. We had various serial parallel communication protocols as well as various communication standards. And later we came to discuss the memory devices, memory elements of an embedded system and also the various device drivers present in an embedded system. This was done in the third unit. And finally, having known about all the components of this embedded system, we decided to understand the software programming concepts of the embedded system in the fourth unit. So there we had a conceptual understanding of various OOP languages like Java and C++. So that's where we stopped our sessions. Now let's get into our fifth module, operating systems. So this word operating system, I'm pretty sure that it's familiar for all of you. For you, an operating system, perhaps it may be a Linux operating system, it may be Windows, Ubuntu, the Android operating system or even the Mac OS. So when I tell the word operating system, these images or these words may perhaps come into your mind. Now what does they do? If you are using your PC, you may have a Windows operating system or Ubuntu operating system or any kind of Linux operating system. What is the difference between these operating systems? Or what specifically is the task of an operating system? Let's say, consider we are using your laptop, your personal computer PC, right? You are the user, you want to do certain task or certain application in your PC. So what are we going to do? Your user or I am going to use the resources in my system. Can I directly go into the system's memory and give data or programs into it? I can't do that. So if the user want to access any of the system resources, we need some kind of intermediate between them, right? Or I would say you need some kind of a bridge between the user application, which is you, and the system resources in your PC. That bridge is given by the operating system. It may be the Windows operating system, it may be the Ubuntu, it may be Linux, or coming to your mobile phones, it may be the Android or even the Mac OS. So basically, an operating system, they form a bridge between the user application, here you are the users, and you want to use the hardware in your system. So an operating system does the task of connecting the user to the hardware through a set of functionalities. So basically this functionality will involve the resource allocation and resource management, right? So I can define an operating system as the bridge between the user application and the underlying system resources. How do they do that? Through a set of system functionalities and services. Well, the OS or the operating system. So what they do is their primary task is to manage the system resources, and they'll make sure that your system is convenient to use, and they will organize and manage the system resources efficiently and correctly so that you or the user can have access to the resources which are allotted to you. So the time of allocation and what all resources you can use is determined by the operating system. I hope that is clear. So an operating system makes sure that the user application, which is you can access the system's resources and do your specific task, right? So just like we have the processor as the core of an embedded system, and a CPU is the core of a processor. Just like that, the operating system also has a core operating part, and that is called the kernel. The kernel here is responsible for managing the system's resources, as well as they make sure that there is a proper communication between the hardware and other system services. So it is a job of the kernel. Whenever I say operating system as such, it is the kernel who is responsible for managing the resources. And it is this kernel which is the core of the operating system. Thus, kernel is acting as the layer between the system's resources and the user application. If you remember this previous figure, I'm sorry. Yeah, here we can see these are the kernel services, right, which connects the user application and the hardware. And the kernel services has a set of functionalities or services, right? A set of duties that the kernel services are doing. We shall see each of them in detail. So that's what a kernel does. A kernel is the main part of an operating system, or it's the core of an operating system, and it is the kernel who manages the system resources as well as ensure the communication between the hardware and other system services. Now basically the kernel is nothing but a set of library functions and services. And what are these different services? Let's see. They involve process management, primary memory management, file system management, input-output system management, secondary storage management, protection systems, interrupt handlers, so on. So let's see each of them in detail. Well, when I say process management, just imagine it to be a manager of a company or any organization. See, what this process management unit is responsible for is, they just set up the memory space for your process. They make sure that your process, whatever task you're doing, they have a memory space. Once the memory space is allotted, they make sure that you can load your program's code or process program into the memory space. Okay. So what do? They will first allot a memory space for the process, and once your process is ready, they will load your process program or software codes into the memory space. Once that is done, they can allocate the system's resources, which all registers you need, which all memory sections you need. So whatever resources are required, do you need an input output port? So all the resources are then allotted to your process. And once that is again done, they will make sure that your process has a particular scheduling, and they will manage or determine the execution of the process. Right? So process management, they deals with the execution of the process, the memory space needed for the process, the resources needed for the process, the scheduling and execution of the process. All these are determined in the process management stage. Clear? Next thing that comes about is the primary memory management. Well, see, when we say the term primary memory, what you can relate to is a RAM, right? The random access memory. So it is here where we load our processes, the variables, shared data, everything is loaded in this RAM. So the primary memory management is responsible for knowing what part of memory area is being used, what part of memory area is now free, what amount of memory will be required for your process. Anything and everything related to your primary memory is managed in the primary management unit. How much memory is currently being used, how much memory is required for a process, how much amount of memory is free for a process. So all those things are determined by the primary memory management. Yeah. The third thing is the file system management. The third service provided by kernel is file system management. Now what is a file? For us, files may be a word file, image file, video, audio files. Yeah, that's the same case here also. A file is nothing but a collection of information. It may be text files, images, audios, videos, word documents, whatever be your information source, you can call that a file. So this file system management, what they do is they are responsible for the creation, deletion and alteration of files. You can create file, delete files, you can alter the files. Everything is controlled. Everything related to files are related by the file system management. Right? The fourth service provided by the kernel is input-output system device management. Again, having known all these three, you can easily guess what are the other jobs. Input-output system management, right? So we have various input-output devices which may be connected to your systems. So here the kernel makes sure that your input-output request to access an input, request to give an output to an output port, which comes from different user applications, they are properly channeled. The kernel ensures the routing of the input-output request which comes from different users. Okay, so the which user can use which input, which output, these are determined in the input-output system management. Right? Now, you may guess what are the job of secondary storage management. Manages the secondary storage devices. Now, what are the secondary storage devices here? It may be a hard disk, right? A commonly known secondary memory is a hard disk. So this secondary memory, we basically use them for the backing up of programs or data. Since our main memory is volatile, you may need a backup which is provided by the secondary storage. So the secondary storage management service of the kernel They are responsible for the disk storage allocation, disk scheduling, which is the hard disk, right? When I say disk, it is hard disk. Hard disk storage allocation, hard disk scheduling, free disk space management. So all these things are controlled under the secondary storage management. Yeah. The next service is the protection system. So what may be the protection system? See, nowadays when we install a particular application from Google Play Store or any other application, when you're installing a app, they request access to various folders, right? Maybe contacts, maybe images, maybe documents. So they request permission to access various documents. If it is Facebook or WhatsApp, they need or they demand access to our contacts, images, documents, everything, right? Almost all the applications. But certain small applications such as say Google Maps, nowadays they access a permission to almost all the things, but it's simple, just a map. A map primarily need access just to your location services, right? Whereas a social platform like Facebook or WhatsApp, they need access to your contact, images, your files, all the documents, your browsing history, everything. So the depth of the access permissions depends upon various applications, right? And how can you give the permission to these accesses? You need certain amount of protection, right? So this protection system deals with your security policies, how much you can restrict your access. So for a system, they can restrict access to both the user and the system resources. When you are using a laptop, you have your users, right? Multiple users. For a guest user, you may not allow the access to various files or various folders, your personal as well as professional folders, right? Only the main user or the administrator can view all the files. So there we have controlled your access just for the protection. Similar way, your operating system or specifically the kernel can control the protection systems in your device, right? And finally, the interrupt handler. You can handle the execution, the permission to access an external interrupt or an internal interrupt. So these are handled by the interrupt handlers. So these are the services provided by the kernel. Process management, everything related to the process, their memory allocation, their loading your program into the memory, executing them, scheduling them, everything is controlled in the process management. Primary memory management related to accessing your RAM, amount of memory available, amount of memory used, everything comes under this primary memory management. Later, the file system management, what are the files that you can access, when, how and by who. Here again similar, see these both are similar, I have to say. Here it controls the accessing of your information. Here they control the accessing of the input output devices, that's it. Then secondary storage management, controlling the memory required and available in your secondary storage, which is basically the hard disk. Protection system to control the amount of access given to various resources. That's it. So I hope you have got an idea about what is an operating system, what is a kernel, what is the function of this kernel and this operating system. If this concept is clear, let's move on to our next topic, the process. Right. So when I say a process, we are very familiar with this word process. So in the case of an operating system, a process is nothing but a program. A process is a program. There is one condition to it yet. A process is a program which is in execution. You may also call your process as an instance of a program in execution. See, it's just a program which is being executed right now. That's it. Right now I am taking a video lecture, which means my process is I am taking a video lecture because this process is being executed. Right? So a process, it may be a whole program or it may be a part of a program. It is a set of program codes, right? It is a set of program codes which is being executed. Now, if process is a set of program code, then it will need various system resources, right? If you want to execute a program, you will need the CPU to execute the process. You will need the memory to store the codes, and not only the codes, the data and related variables. To store all this, you need the memory, and you also need the input-output devices to exchange your information, right? So a process is simply a program which is being executed. Because of that, they need a number of system resources. Since it is a program being executed, so they need a number of system resources. CPU for executing, memory for storing, and input-output devices for information exchange. Now, this process, as I have said before, they consist of executable programs and their state. The state of the process may be running, blocked or finished. We shall see what are these states, and the structure of the process and the PCB, we shall see in details what are these. Now let's see the structure of a process. Here you can see the structure of a process. What does a process have? They have the stack, working registers, status registers and program counter. Now tell me, what are the duties of this? We are familiar with all these components, right? The process needs a program counter to find the next executable instruction of the process. Just like our normal PCs, they point to the next instruction of the process. Now the stack, they store the local variables, right? Status registers to show the status of your process, if it is completed or if it is running, if it is blocked, if it is created. What is the status of a process? That's shown by the status registers. And these working registers is like a normal registers. They may store your data or any interchange values. This is stored at the working registers. So a process structure is basically this: the program counter to point to the next instruction, status register to show the status or the condition of the process, the working registers to store variables or data, and the stack, similar duty. Only thing is the stack store the local variables. So since the process has all these components, I can say that the process mimics a processor, because they try to copy all the elements that a processor has. PC, registers, status register, stack, everything is available for a processor, right? So the process also has all these components. So I say that the processor mimics or copies a processor. The process, did I make it wrong? I'm sorry. The process mimics a processor. So this is the basic structure of a process. Now let's see what are the elements of a process. Each process will have a PCB. the process control block. What are the elements of a process control block? We'll see soon, right? So any system can have a number of processes which are being executed, right? Now, what is the memory organization of a process? What are the memory that a process has? As it is very evident from this figure, they have the code memory, the data memory, and the stack memory. Now, what are the duty of these? Right? See, the stack memory, as we have said earlier, for the stack, they hold all the temporary data, such as the local variables. Fine. The data memory, they hold the global data. Here it is the local data. In data memory, it's the global data. And finally, the program to be executed by the process is stored in the code memory. So these are the three sets of memory that a process has. The code memory for programs, data memory for global data, and stack memory for local data. As it is shown from the figure, we can see that the data memory always grows upward. Just like putting up a pile of coins, it keeps growing upwards. And the stack memory, they grow downward. So this is the memory organization or memory allocation needed in a process. Now let's discuss what are the states or transition states in a process. Here we can see the created, ready, running, blocked, and completed. The state in which a process is created is called the created state. So, in this created state, the process has been recognized, but no resources are allotted to the process. You have created your process, but they don't have any resource allocation. When the created process has been allotted resources, or when I say resources, it's basically memory, right? So once this created process has been allotted resources, has been allotted memory, and they are waiting for the processor to call them for execution, then it's in the ready state. Created, your process has been created, no memory. Ready means process has been created, they have a memory, they are waiting for the call from the processor. That's ready state, right? Now, when your processor, the memory allotted processor, is being executed by a processor, it's called running state. When your process which has been allotted the memory is being executed, it is called the running state. Now, when a running process has been temporarily suspended, when the running process has been temporarily suspended, it enters the block state. And if the block state has been removed, then they goes to the ready state, they again go to the running state. Once the process has completed the execution, they reach the completed state. I hope this is clear. I shall repeat it. Created process without resources, they lie in the created region. Once the process is allotted memory and resources, they are in the ready state. They are waiting for the call from the processor. When the process is called by the processor for execution, they are in the running state. While they are running, if they are suspended for some time due to any external events, they are in the blocked state. In the blocked state, if they get the resources once again, they come to the ready state. When executed, to the running state. So this can happen anytime, this blocking condition. Once this execution has been completed, they reach the completed state. So this set of cycles, or the transition from one state to another, is called the process life cycle. From creation to completion, whatever states and transition the process goes through together is termed as the process life cycle. So in fact, this life cycle gives us an idea about what are the stages the process goes through, right? So we have seen what is the process structure, the memory required for the process, as well as the states in the process. Now let's see what is the process management process. Well, the process management, as we have seen earlier, it deals with the creation of the process, setting up or allotting the memory space for the process, loading the process code to the memory, allotting the system resources, and setting up a PCB or the process control block. Just like a manager gives the memory, loads the program, allots other resources, and finally ensures the state and other things of the process. That's the task in the process management. Now we have seen this term PCB in a number of slides. Let's see what is a PCB or what is a process control block. We can easily guess from this name, process control block. Since it's a block, it may be some kind of a data structure, right? Control block, perhaps maybe control elements to control what? The process. So the process control block may have elements which may control the operation, the features of this process. Now what are those elements? Let's see. So process control block is simply a data structure having the information using which our operating system can control the process state. So it has a set of information, right? It has the process ID. By what name you can refer to your process. Suppose you have 1, 2, 3, 4 processes. So the first process, I name it process 1. Second is process 2. Third one is process 3. So these are the process IDs for a particular process. Process priority. So in what priority or in what order must you access the process? It can be the PCB has details about the process priority, as well as they have information regarding the program memory allotted. It may be in the physical memory as well as the secondary memory. It also contains the process specific data address blocks. I hope it is clear from the sentence itself. The process specific data address blocks, it has access to all the address allotted for the data which the process needs, just for that particular process. Process 1 needs a set of address blocks in registers A, B, C. So those information is included in your PCB. It also includes the process heap. See, process heap means while we are executing a process, we have certain outputs, right? Or certain data which are generated. So those data are called heap. So PCB has access to these regions also, these data also. And they have the allotted process stack address. I guess I don't have to say this, the stack address for the functions. So the memories where the stack or the local variables have been stored, these are also mentioned in the PCB. And along with that, they have addresses for the CPU registers where your values or your data are being stored while your execution. The address for CPU register save area as a process context. the process states, signal mask, your states just be so the created, ready, running, blocked, completed, all these state and their statuses are stored, and um, the signals that a process transfer or receive, all these things are included in the PCB, right? The resources and the security restrictions, each and every thing related to a process can be found in the PCB. So basically they include the process ID, their priorities, and a set of memory locations for the program memory, for the specific data, for the heap, for the stack addresses. All these memories are stored in the PCB, right? Everything. So that's about process. So we have seen that in this session, in this video session, we have seen what is an operating system, a kernel, and what is a process. We have in detail seen what is a process. It's nothing but a program code in execution. So there we have seen the structure of process, the memory requirements, the states, and the PCB. PCB is a very important or the most important section for a process. In fact, the PCB, the process control block, defines the process itself because they have all the information related to a process. So I hope this session is clear. Once you listen to this video, also please go through the notes which are provided to you so that you can clearly understand the concepts. If any doubts, please let me know. That's it. Thank you.